So this article in particular comes out on the heels of this. GPT-5 Pro sets record at Frontier Math. What does it mean, and what are the implications here?
Yeah, I think this is arguably the most exciting development over the past week and a half. So as a reminder, Frontier Math Tier 4 consists of math problems that professional teams of mathematicians would take a few weeks to solve. These are very hard math problems. And over the past week and a half or so, we've seen first Gemini 2.5 DeepThink and then GPT-5 Pro demonstrate breakthrough performance, GPT-5 Pro at 13% on Frontier Math Tier 4. And Dave insisted that I make an internal recorded prediction for just to get on the record, what would it mean for math to be solved in quantitative terms? And this is months ago. And I put on the record, as Dave will, I think, attest, we can reasonably declare that math has been solved when Frontier Math Tier 4 passes 10% scoring. So more than 10% of the problems can be solved by a bleeding edge model. And the reason why I picked 10% is because at some point in the logistic regression of like predicting, you've solved 10%, at some point you just pour compute on and you get more results. I think we've seen this over and over again. We saw this infamously with Ray Kurzweil pointing out that you're halfway complete with sequencing the human genome once you've passed 1%. 10% is sort of my arbitrary benchmark. I predicted that we would be past this by the end of this calendar year. Christmas arrived early. Math is now on a trajectory. If you just pour more compute on, arguably with no new innovations, math will be solved, at least math as we currently know it.
Okay, so when math is solved, I've asked you this before, but I just want to hit it home because it's a kind of an esoteric subject for most people. What does it mean when math is solved? What's the implications for all of our subscribers here?
It's the ultimate canary in the coal mine, as it were, for solving physical sciences, solving engineering, solving medicine. If we can have machines that solve arguably humanity's most rigorous intellectual endeavor, which I would suggest is math, then everything else I would expect over the next few years, call it 5 to 10 years, I expect to succumb.
As a tangible example, encryption is all math-based. So when you can have an AI deliver that, you can kind of get super encryption at whatever level you want instantly.
And
So
physics and material sciences, yes.
Yeah.
And all of the physical sciences. And conversely, as I've articulated in the past, any discipline that relies on math, or at least the current math being hard, is also in danger.
So it's not just learning math, it's inventing it at some point pretty quickly.
Absolutely.
Okay.
Yeah.
Wow.
Yeah, I think just the implications, one thing people misestimate continually is if some brilliant mathematician, human, solves a hard problem, that makes the news. But it doesn't imply that all other problems will be solved the next day. The AI version of the same achievement,
Great point.
like in biotech, in math, in physics, and all these other areas, because it has near infinite scale, instantaneously, if it can do one frontier math problem, it's very close to being able to do many and then billions, just right after that. And so people need to factor that into their rate of change thinking and as it cracks these different areas.
You better find some more problems.
This is dominoes falling and heading towards, again, Alex's words, solve everything.
It's bulk discovery, and we've only seen this in narrow areas. We saw this with AlphaFold 3 and protein folding, where almost overnight we had arguably high-quality protein structures for most known proteins. We're going to see bulk discovery across a number of disciplines. The other story here is, we don't have a slide for this, but the Erdős problems. This is a set of order of magnitude 1,000 problems that were identified by famous mathematician Paul Erdős. AI and GPT-5 are being used to bulk solve those, and the solutions are starting to pour out. If you go to the Erdős Problems website, you'll see just in the past few days now, there are folks who are just bulk applying GPT-5 to all of these open problems, and they're getting switched from open to solved.
Wow.
Don't sleep, don't blink. It's happening. All right, let's move on to this one. OpenAI on building chips with AI. Here's a quote from Greg Brockman. We've been able to apply our own models to designing this chip. We've been able to get massive area reduction. You take components that humans have already optimized and just pour compute into it, and the model comes up with its own optimization. Dave, talk to me.
Yeah, I love this story because this is it ties together so many things we've been talking about. One of them is the short timeline to about 100 to 10,000x improvement in AI performance because of the AI self-improving. And when we say AI self-improving, a lot of people in academia are like, well, it's not that smart yet. But it is, because AI self-improving is nothing more than math, algorithms, and chip designs. And it can do those point tasks. And then a lot of the academics then say, yeah, but that's not true reasoning. That's not true genius. That's not true whatever. It doesn't matter, because that's all you need to do to self-improve. And so I just love this story. I also love the fact that, Greg and Sam out of the original cast at OpenAI are the two guys that dropped out of college, didn't finish undergrad, and they're the two survivors. And so you take take Greg, the guy that dropped out of MIT, he's designing chips now because he's a master of AI. And I don't know if you guys did any VLSI design or chip design at MIT. I did a fair amount of it, actually doing neural net designs. And it's absolutely laborious. And the amount of improvement is incredible if you just had the time and 10,000 people to work on it. Yeah. And so AI is just going to rewire and redesign and relay out the thing, and the simulators are near perfect.
It's an acceleration of the acceleration.
It's so cool. It is to me.
I can attest to this. One of my student jobs at Waterloo was to run field tests for VLSI boards, and it was like freaking linear painstaking hell.
Mm-hmm. Yeah, and so the other thing this ties in is Leopold Aschenbrunner buying Broadcom stock. And you're like, okay, I didn't see that one coming. Why is he? And of course, you can see it in his 13F filing, but now it's obvious, right? Brockman is designing chips. The chips need to go to Broadcom, and then they get manufactured on TSMC. Therefore, Broadcom stock is the one that Leopold buys. And of course, Leopold was at OpenAI and knows Brockman. So it all ties together.
You mentioned something that I think is important. Again, we hit on this sort of week on week, that Sam and Greg dropped out of college to go and pursue this. And, one of the things you and I have discussed, Dave, is majority of the entrepreneurs who are succeeding today aren't the ones who have gone on to get PhDs or gone on to do graduate work, right? They're ones that have launched either just after college or have dropped out of college to go pursue it. And it's almost as if going to get your graduate degree and going very narrow into a deep, it's like, I remember if I was going to explain to my grandfather what I did when I was at MIT, he says, okay, you're an expert in, and I would say to him, like, look, in the dirt over there's this thing called this bacterium. And he goes, oh, you're an expert in that. No, I'm not an expert in that. In the bacterium, there's this thing called DNA. You're an expert in that? No. In the DNA, there's this thing called a gene. You're an expert in that? No. In that gene, there's a promoter sequence, and I'm an expert in that, right? And so our graduate work right now is this hyper narrow focused effort instead of being able to step back and look at, reinventing an entire field.
Yeah, I'll put a slightly different spin on it too, which is the people Greg's age and Sam's age that dropped out had very high situational awareness around the urgency of what's happening right now. If it were 2001, and 9/11 had just happened, going and getting a PhD would make a ton of sense because the world isn't moving at warp speed during that time frame. But the reason the undergrad dropouts and the other people just graduate and start a company right away are way overperforming is because they recognize the urgency of the moment, and they know that 4 years from now is just not a good choice in this moment. So it's that.
Well, also their brains haven't been calcified by studying that one thing that Peter talked about. I don't know how Alex broke through all of this. Somehow he's like smarter
Paul
than
Graham
everybody.
calls it the hardest lesson to unlearn. It takes a lot of unlearning.
Yeah.
Crazy. All right. Let's move on here. Sora hits 1 million app downloads in less than 5 days, faster than ChatGPT. I remember when ChatGPT came out, I was doing a podcast. I was like, oh my God, 1 million downloads in 5 days, new world record. But something is going to beat that. Well, here it is. It's Sora 1 beating that in the App Store. And of course, something will beat this as well, probably within the next year. Dave or Salim, what's your thought here?
Well, one thing we're seeing here, I was talking to the CEO of PacFi 2 days ago, really thriving marketplace company, and they were asking for my advice on how to implement AI within their product. And I said, well, just ask the AI. And so what you're seeing here is more and more of what you do next is what was recommended by the last thing you had on. So if you're a Gemini user, you go with Gemini. If you're a ChatGPT user, you go with ChatGPT. But you say, hey, I want to create an amazing video. What should I do? It tells you what to do. And then 9 times out of 10, you just do what it said. And so the distribution of these new capabilities is actually within the AI installed base. And that's why it's got this self-reinforcing loop.
I mean, I would have expected nothing less, just because the next thing will be 2 days and the next thing will be 1 day. And as Alex points out in our earlier conversation, at some point we'll get the ability to upgrade everybody at the same time. And then that's what Ray, I think, is talking about.
Yeah, for sure. All right, I'm going to turn to you on this one, Alex. Samsung's tiny recursive model redefines AI efficiency. So researchers have built a mini AI model at Samsung with 7 million parameters to test reasoning ability. And this compares to models with billions or trillions of parameters. So talk me through this, Alex.
Well, I would say at a high level, remember first that this revolution, this soft or gentle singularity, if you will, that we're living through was arguably the result of just compressing information. That one of the biggest lessons I take away from how intelligence was arguably solved is just like you could take a lot of matter, and if you compress a lot of matter in a tiny volume, you get some phase transitions, and ultimately you can recover free energy, for example, via fusion. Similarly, if you take a lot of information and you compress it down into a model that has a relatively small number of parameters, at some point you get intelligence out almost for free. That's like a big meta lesson in my mind from the past 10 years. So there's an enormous amount of opportunity for taking large, hard problems, large information spaces, and compressing them down not to models with billions or hundreds of billions of parameters, but to models with millions of parameters. I've also spoken about my expectation, this is one person's speculation, that we're marching toward an ultimate end state where we'll achieve like a perfect model. It's like a microkernel. It's like a diamond of a model that may not even may not consist of differentiable end-to-end parameters. Maybe it'll only be 1 million parameter equivalents or 1 million bytes or something like that. And when I see progress like Samsung's TRM, which looks, it's a lovely paper. If you look at the architecture, sort of resembles a diffusion model in some sense. The premise is it's domain specific. And in this case, in the case of the result you're showing, it was trained on a bunch of examples for the ArcAGI 1 challenge that we were talking about earlier. Has a notion of a scratch pad, but it's a relatively tiny model, and it rewrites the scratch pad several times and then goes back to work. It has some latent expectation of what it's trying to do and then rewrites some more times. It looks like a diffusion model if you squint hard enough at it. But I think that the big takeaway is such a tiny model achieving breakthrough performance. You know, if folks who can see the chart here, it's competing with O-class models in terms of price performance, but it only has a few million parameters. So I think
so. The implications are what? You've got this on your phone. You've got this on every device. Even if it's not connected to the internet, it's able to deliver you intelligence.
Oh, the implications are so much bigger than just that. Yeah. Sorry, Alex, go ahead. We're going to say the same thing, I'm sure. Well, I mean, look, if you can take, normally to achieve that same level of performance, you need about on the order of 1 trillion parameters, say 700 billion, just to keep it simple. So you go from 700 billion down to 7 million. Then you can use all the rest of that compute capacity to expand it again and make it better at that domain. So if you can take a general massive model that costs, $1 billion to build and compress it down to a specific use case like protein folding or, just longevity related use case or just chip design related use case, get all that original capability, but now you've got it in a very tiny package, then you can start training it out, reuse those billions of parameters to make it much better at that domain. And so you have this combination of many, many effective workers, many agents working on the problem, plus the ability to build back out the intelligence level with more and more data, purely through this process of distillation and expansion. It's the most powerful thing in the world. And it's also really, really empowering for a whole new wave of startups. And I don't want to get too deep into it, but we could talk about this for hours. But I think this slide encapsulates the most profound idea in all of intelligence, which is, so it was something that Ilya Sutskever said at MIT with Lex Friedman about, it must have been like 7 or 8 years ago at the dawn of this wave of AI, that compression and intelligence are actually the same thing. And everyone goes, what that makes no sense
This is the
to me.
point
I don't
Alex
get it.
has been making, right?
Yeah.
That's right.
Yes, yes. And this is why
Wow.
Alex says that intelligence is going to turn out to be everywhere. There's going
Well,
to
you
be.
look
think
at
I'm gonna name
DNA
this-
and how much is packed into a few DNA, a few genes, right? It's the
That's
same
right.
basic principle.
I'm going to name this episode "The Singularity Is Now." That's how
Wow.
I'm feeling.
Okay. But here's two questions about this.
Yeah.
One, does this obviate the need for all the radical energy expansion, or do we just have so much compute to do that we need it all anyway?
No. We're going to chew this up so fast because the,
The
capabilities
second thing that occurs to me is right now when we run these big LLMs, it's kind of a mainframe model. This is kind of tilting towards more client-server type architectures.
distributed.
Okay.
Like no,
The
that's a
foundation
huge deal
models are going to be
do an hour.
everywhere in your pocket, in your body, and out in the cloud.
Amazing.
Yeah, let's come back to that. Let's file that away because that's Salim, what you just said is also hugely important and profound. This distributed training concept.
Yeah.
So let's come back to that.
All right, our next article, diving into Anthropic, introducing Claude Haiku 4.5, which delivers near-frontier coding and reasoning performance at one-third the cost of Sonnet 4. Let's play a quick video here. Well, it's playing without sound, and it's just showing its capabilities here. Alex, what do you think of Haiku 4.5?
So I ran it through one of my, I have a suite of evals, a suite of tests or benchmarks that I throw at CodeGen models and classes of other models. So my favorite eval for new CodeGen models, and arguably Haiku 4.5 could do more than CodeGen, but I ask it to generate in one shot, a visually stunning cyberpunk first-person shooter. And Haiku 4.5 was able to do that to near perfection, but critically was fast. It's a very, very fast model. So I maybe wall clock time 30 to 45 seconds before I had a playable cyberpunk FPS that was lovely.
That's stunning.
That's nuts.
Stunning.
That's
All right,
now.
congratulations, Anthropic, on that one. Moving on, here we have Google, kind of a pre-announcement, but the drums are beating off in the distance that Google is getting ready for releasing Gemini 3. Likely this December. It turns out that Google has released its Gemini models in December over the last 2 years. And of course, once Gemini 3 drops, the Moonshot Mates are going to be there to explain what happened, what does it mean, what are the most exciting attributes in it. Any other thoughts here, Alex?
It'll be interesting to see with this annual cadence how quickly all of the frontier labs leapfrog each other. I do think there have been reports of an experimental checkpoint floating around the internet, preliminary release of Gemini 3 that is really impressive if the reports are accurate. Fluent music, graphics, 3D generation. So I'm very excited to play with Gemini 3.
Yeah, we're
once
going
it's
to
out.
see that in our next slide here, or listen to it in our next slide here. So purportedly, this is from Gemini 3, that it can now compose original music. Let's take a listen to this as you're sipping your coffee or driving your car. It's gorgeous. What are the implications of this? What do you guys think will come
Well, hold
out?
on. Let me ask a question, because that just sounded like Chopin to me. And we've had for a while the ability to say, hey, play me something like Chopin, it'll play you something. There's something that's happened here. What am I missing?
What I think is interesting is that this is MIDI generation. This isn't generating raw waveforms or wavelets or raw audio, as we've discussed in the pod in the past, like Suno 5. This is treating music as an almost first-class modality. There are a variety of languages like ABC notation or MIDI notation. And what I take away from demonstrations like this and others that are allegedly floating around from this experimental checkpoint is Gemini, despite whatever limitations in its omnimodal training data set, has the ability to understand music notation and music languages as a first-class modality. That sort of transfer is highly difficult and non-obvious. If you've ever tried to ask like an Oak class model, say in years past, to generate compelling music, it was very challenging.
Well, Andrei Karpathy just kind of emerged and started podcasting again out of nowhere, and he made the point that these capabilities are using the same generic neural net design, transformer design that the language models use and that the self-driving car uses. And so the implication of that is that, look, it's exploding into these areas purely with more data. There's no, hard, heavy lift for humanity to design something new to make this work. You just put in more data, and now suddenly it can do MIDI, actual music creation. But that implies that there'll be something next week and next week and next week and next week. It just as quickly as you can gather the data, it's developing these new abilities.
I want to double click on that because I don't think majority of people understand that these models, when we're hitting these scaling laws of more data, more parameters, more compute, are evolving capabilities that were never predicted. It wasn't like we tried to build these capabilities. It's like they're emergent properties as the systems are becoming more intelligent. And that's fascinating. Scary in some ways, but fascinating.
And hugely important, Because when people see a new capability like this, they assume that some team was grinding away on it for 20 years in some basement and it just got launched. That's not the case. This is just a purely emergent capability on top of the core platform.
It's like, oh, wow, look what we can do now.
And so ironic, Peter, I mean, when I was an undergrad at MIT, one of my first research advisors was Marvin Minsky, and he would slap my hand every time I used the word emergent. He would say, no, that's preposterous. Emergent, using that word just means you don't know what you're talking about. And yet, ironically, decades later, in fact, we see all of these emergent capabilities.
Amazing.
We should do a whole episode on things they told us that turned out to be wrong. There's a bunch.
That would just take too long. All right, let's go on to another property that's been announced for Veo 3.1. So DeepMind releases the next image video model. Let's take a look at a quick video about Veo 3.1.
New enhanced capabilities give you control like never before. Let's take a look. You can use a reference image. Veo puts them together into a fully formed scene, complete with sound.
Hello, is anybody here?
You can extend your clips and transform any shot into a full scene. Reimagine any shot by adding or removing elements, from subtle details to impossible objects. Veo matches scale, lighting, and shadow for real-world physics and cinematic outputs. Live with audio, using sound effects and dialogue.
Just gotta listen.
I mean, incredible, right? So there are three critical differentiators between Veo 3, which was amazing in itself, and Veo 3.1. The first that they point out is superior audio quality and synchronization, and you could hear that when it was cooking the food in the frying pan. It's much richer, more natural. The second, which I find fascinating, is you can give it three ingredients, like, here's an image of a person, here's an image of an object, here's an image of a room, and it will take those three effectively and tell a story around those three, combining them. And you can give it a opening scene, like, here's the starter image I want you to start the video with, and here's the ending image I want you to end it with, and it'll create a logical construct that goes between those 2 points. I mean, pretty amazing. Other comments on this one, please?
Yeah, well, so a couple of our friends have made full-length movies now, and to do that, it only gives you a minute or two back at a time, and so you have to take the ending image and use it to stitch together the starting image, which is frustrating because they could do that automatically. They just don't have enough compute to keep up with all the people that want to use this. But you can do it. You can hack your way around it and make incredibly seamless full-length movies all of a sudden. And if you go back just 6 months ago, actually remember 18 months ago, Peter, you had Aristotle and Plato on stage at Abundance 360 debating with each other. And if you look at all the comments from the movie crowd, the producers, the Paramount Studios crowd, they're like, yeah, but. And if you look at the list of yeah, buts, almost every one of them has been solved in less than 18 months. But the characters aren't consistent from scene to scene. Yeah, but it's obviously digital and you can see the seams between the scenes. The physics aren't quite right. The arm detached from the body. Every one of those things banged out in this, less than 18-month timeline.
extraordinary. And we're going to be at the Abundance Summit this year. We're going to be diving into this again. What's the implications for Hollywood and, in particular, the creator economy, right? I've got a project, a secret project. I can't talk about it yet, but working on with Google around production of content like this, and we'll be releasing that hopefully in the next couple of months. Salim, do you want to comment on this?
I don't fully understand the implications of this, except if you can go end-to-end, not per scene like this, then stitching together a whole movie becomes every amateur can now go full on, right? And that completely changes Hollywood radically. I guess we'll see an explosion of consumer-generated movies now with all sorts of weird plots, etc.
Oh, I suspect, I don't know, but I suspect that there are many, many people all over the world that have something to say that could never get the attention of a studio or an actor before. And now they don't need it. Now they can individually put something professional studio caliber together to illustrate the point they were trying to make. I think that's going to be a crazy explosion in
And
society.
what a win for YouTube, right? I mean, Google is sitting pretty because the only distribution engine for this explosion of content
That's right.
is going to be on YouTube.
I also think with some of these models, VO 3.1 and Sora 2 Pro, for example, these are just training wheels for video-based reasoning models. I think that will generate an enormous amount of additional economic value. So generating consumer-grade video, this is wonderful. This is radically democratizing Hollywood. Excellent. But then imagine now we're about to have reasoning models that can think